Hey, everybody, welcome to the Machine Shop Growth Podcast. I think, like you guys heard last week from Mike, we are changing things up a little bit. And what we're trying to really do here is get you guys some more focused content. You know, what we are kind of going at before with Mike and I doing things together was more of a birdshot approach where, we would come at you with different topics and ideas and things like that. And we would just, you know, throw everything out there. And instead of that, what we're trying to do now is we're trying to refine back a little bit about what we do, what we talk about, and things like that, and get it a lot more focused for you, so you can get a little bit more value out of kind of what we're talking about instead of you know just brushing over high level everything. Mike's looking more in the sales and marketing. I'm looking more in the operations and basically how you do what you do in a machine shop. So we always talk about there's three facets to machine shop growth. You got top line, bottom line people. And so what sales and marketing really focuses on is top line growth, right? Uh, you can go sell a part, you get it, you get the PO, you put it in your ERP software, whatever, and that's it. That's all it is. It's just top line. There is no bottom line to a part until you make it. Period, because you have no cost associated, right? So my side on the ops side is focused on bottom line. How do we take that sale and how do we make money? That's ultimately all what operations is. Everything operations is bottom line. We are where the rubber meets the road. It determines whether you make money, whether you lose money, whether you grow, whether you die. That is your operations. And not to take anything away from sales and marketing. Sales are incredibly important. If we don't have sales, we don't have anything to do, right? But how we do what we do is what determines where our bottom line ends. Okay, so in this first episode for the first episode of 2026, one of the things that Mike and I talked about going over was how do you start your new year? How do you set some goals, some objectives, some different initiatives and things like that for the new year, like to get going on the right foot. Okay, so I kind of broke down into a few different categories here, and the first one is the most basic KPI. And a lot of shops do this, especially in a lot of the smaller shops, a lot of the shops kind of getting off the ground and things like that. Do I have more money in my bank account now than I did this time last year? I mean, that's a pretty basic KPI, right? If I made money, I should have more money. If I lost money, I should have less. Did I have to, tap into a line of credit, run up a bunch of debt and things like that? It's pretty simple, right? And then, stepping into the next layer of a KPI, yeah, on-time delivery in your quality and scrap rate. Um, those things are something that every shop should monitor, and most shops do monitor. However, this metric is a lot more of a supply chain metric. This is how you're graded at your customer. How many quality rejects do we have, and how many times do you send us parts on time? And that goes on your scorecard, and that determines a lot of times what kind of new opportunities you see, and how it strengthens or enhances your relationship with them based on whether you can deliver parts on time every time and they're right. So, I see a lot of this stuff floating around, and it's all good stuff to track. Don't get me wrong, but it's like the very broad view of the actual KPI you need to check it, and you need to be diving deeper into. And what we're going to go over for the majority of today, that's going to basically tell you everything you need to know about your shop, and it's in one metric. It's a very complex metric. There's a lot of different inputs and things like that have to go into this. And the most important part is accuracy and data recording, right? Your data collection has to be accurate, or this metric is going to be totally useless to you because, you put good in, you get good out. And if you fail to keep track of your inputs for 50% of the year, well, you're getting a 50% accurate answer. So what we're going to talk about today is OEE. overall equipment effectiveness. This is probably one of the most important metrics to track in your shop because it's telling you a lot of different pieces of information, which will kind of start to peel back a little bit. So, what is OEE? Obviously, in the name, it's telling you how effective is your equipment. What efficiency rate are you hitting in your manufacturing process? You can do it by employee. You can do it by machining center. You can do it by turning center. You can do it by department. Maybe you want to roll up all of your lathes into your turning cell or your turning department and see, how effective is my turning department. You can roll it up into your milling department, your grind, your EDM. You can roll it up to the entire shop. How effective are all these different machine centers and departments? And then you roll it all up into your shop. How effective is your shop overall? And what this thing is going to tell you is, where are your issues? Okay. So OEE is calculated by availability times performance times quality. Okay. Availability is runtime divided by planned production hours. So how much did you actually run versus how many hours did you plan for that? And what this is going to tell you is a little bit of your efficiency. Um, you know, you planned 1 hour. We'll just say you planned an 8-hour shift to make this batch of parts, and for whatever reason, that batch of parts took you 9 hours, right? So you have an extra hour in there. Well, why is that? Well, maybe there's something challenging about the setup. Maybe you didn't calculate in, oh, well, there's bathroom breaks, right? Like some people had to go to the bathroom and the machine sat for 10, 15 minutes here or there, or whatever that case may be. Maybe you're breaking tools, that kind of thing. So what availability is it's really telling you what your efficiency factor is. Okay. And we're gonna go deeper into these a little bit here in just a second. Performance. Okay, performance is actual runtime divided by estimated planned runtime. Okay, so what this is a little bit different than runtime versus planned production hours. Your actual runtime is obviously how long did it take you to make the part on the spindle, right? How many cutting hours were on there? If I'm saying it takes 10 minutes to cut a part and for whatever reason it took 11 minutes, why? Right? And what this has given you a little bit of an insight into is, one, this is more of your machining strategy, your actual making chips type um, metric. But the other side that it gives you into is this can also give you some insight into your quoting, and we'll get into that a little bit. This is sort of an estimated versus actual type of KPI, and we'll get into that in a little bit. And then the last one is quality. Very simple. How many good parts did you make divided by how many pieces of material did it take to make those parts? Um, again, this is probably the most simple and straightforward metric of OEE, but you know, also very important because you can lose a lot of money and time due to scrap. Okay, so let's kind of go back through these for the first item, availability. Okay, like I said, this is kind of an efficiency metric. I have X amount of hours to make these parts, and this is how long it took me to make them. Okay, so what kind of things can this surface for a shop? Well, again, like I said, there's some inefficiency factors with every machine shop. I mean, a human is not going to stand at a machine and run that machine 100% efficiency all day. It's just not going to happen. Everybody knows that. Typically in a shop, you're going to target, and it depends a lot on what you do. If you're doing one-off type parts, super complex aerospace parts, you're probably not going to hit a 90% efficiency. I mean, probably not going to happen. You got a lot of things that happen through the prototyping phase, through the first article inspection phase. When that machine, or I'm sorry, when that part comes off the machine, it's got to go to QC for first article inspection. That's going to be some inefficiency there at the spindle. And Now, it's not necessarily going to be inefficiency as long as you plan correctly, because again, we're talking about runtime divided by planned production hours. Okay, so if I say this part's going to take 10 hours to machine and we've got 2 hours of QC time in there, we have planned 2 hours of downtime in this production run. So that's not going to hit your availability. However, if that part sits for an extra hour in QC because it's, got to wait in the queue for a minute to get on the CMM, that's going to impact your availability. So the whole target for OEE, by the way, is 80-85%. You're doing pretty well if you can hit 80-85%. Efficiency falls right just about in line with that. You want to be at that 80-ish% mark for efficiency. Now, again, if you're doing heavy prototyping, one-off type parts, yeah, you might be a little bit lower, but you can make up for that in performance and your quality, right? It's an average of all the things, multiplied together. Okay, so that's just a couple of examples of things that can hit your availability. Other things, you may have machine downtime. Maybe you have a machine that breaks. And, when you go back and you look at your OEE of a specific machine, maybe you have consistent downtime on this one spindle that, hey, why is it that we're only hitting 30% availability on this machine? Well, it's because it's always broken. Okay, well, then that tells you right there in your planning in your senior leadership meetings, like, hey, maybe we need to look at replacing this machine because it's killing our OEE. We're not even coming close to meeting our metrics because this machine always needs fixed. Or maybe you run a part on, we'll just use Haas for an example. You run a part on a super speed machine, and you get really busy, and you got to put it on this is standard VF2 or VF3. It's inherently going to run slower because the super speeds are capable of higher feed rates and things like that. So you don't change your planning. Now you're hitting a lower availability on that VF2, the VF3. So there's things like that you can kind of catch. Now, of course, moving parts around between spindles, that happens at every shop. And, it's not something that should always happen every time you make that part. So, again, your average is not going to be thrown off that much unless, sometimes things happen in shops where it all gets put on this machine and then it just gets stuck on that machine and nobody knows why. It just does. So this surfaces some of those issues. And what this really serves as is this serves as kind of like a red light, green light, yellow light kind of thing. If you're hitting an 85% efficiency, maybe you got a green light. If you're falling below that, maybe you're 75, 70, 75, maybe you got a yellow. And when you start getting down to the 50%, you've got red. And, the red light's telling you, stop, you need to look at this thing. Your yellow light's telling you, hey, you could do some improvement, but it's not really bad yet. And your green light's like, hey, you're hitting your standard, keep doing what you're doing. Focus on the other lights in the OEE calculation. But, if you got all green, all right, well, you know what? Maybe we can knock a few minutes out here or there. Okay, so performance. Performance does a few things, like I sort of mentioned before. Performance is going to tell you a lot of things about your operation, but it can also tell you if you're quoting correctly or not. And there's a couple ways this can happen. Okay, so let's say we're making a part, and we estimate it to run in 10 minutes, and we discover that part's taking 12 minutes to run. Why? Did the operator go out there and turn a feed rate down? Maybe we've run this part before and somebody didn't like the way it sounded or whatever. Or maybe they turned the feed rate down because they put the tool in a wrong tool holder and they're getting a lot of chatter. They were using the incorrect work holding. Those kind of things. This is your technical and operational metric right here. This is where you're going to look at, and you're going to really have to get in the weeds to figure some problems out ultimately. This one is kind of your bottom line metric. This one is telling you, you know, I anticipated running it in this amount of time, and are we hitting it or are we not? And if we're not hitting it, we've got to figure out how to hit it. But I mentioned this this can also give you some feedback on your quoting. If I quote a part again to run in 10 minutes and it runs in 12, crap, I was wrong. I screwed up. Unless we can figure out how to get to that. Okay, so there's just a couple different ideas or instances of feedback that your performance metric is going to give you out of OEE. It can be operational. It could also be skill. Maybe you have to train your operators on acceptable machining parameters. I've seen a million times that spindle load. Oh, the spindle load gets up to 90 or 100%. We got to turn it down. We're going to break the machine. No, you're not. You're not going to break the machine. That in most machining centers, the spindle load is not actually like a measurement of how much uh, pressure or wear you're putting on the spindle. It's a measurement of how much power that spindle's drawing. It's essentially a voltmeter because we're talking about electric AC motors here. It's telling you how much power is this thing drawing to push it through the cut. Does that translate into spindle load? Yes, but these things are designed to run at or above 100%. Now, every AC motor has a duty cycle, and I mean we can get into all this, but we're not. We're going to save that for a different episode. But the point is, these machines are designed to run hard. I mean, we don't have to baby these things. Um, so maybe an operator sees that and they're like, oh, at a different job, we never let our spindles get over 60%. Well, you got to do some training with your operator. You got to say, look, it's okay. It's going to be fine, and do some retraining. And we don't turn the feed rates down to baby these machines. They're here to make us money. Um, so I guess that's really the three things. It's training, it's your machining strategy, operation, and then it's your quoting. How all those three things really play into this performance KPI. Quality being the third one. Okay, it seems very basic, seems very straightforward. One of the things that I did with the first shop I ever ran was I would have periodic MRB or material review boards within the shop. Every single part that got scrapped got tagged and got put on a shelf. We had sat there on the shelf until we did our MRB. And the reason for that, and the intervals varied. As production would go up, obviously our MRB frequency would increase. If production went down, maybe we only needed to do once a month. Maybe we needed to do it once a week at sometimes. Who knows? But the purpose of an MRB was, hey, what are these scrap parts and why are they scrap? First, can we save them? Can we make this a good part and still ship it? So we would set disposition at the end of the MRB with each individual part. But the biggest and most important factor was, why is this part being scrapped? And we'd start to compile trends, by part number. How many times was it scrapped? When was it scrapped? What machine was it on? Who was running it? And what was the reason it was scrapped? And so what we could see by that MRB is, do we have a trend with a machine? Do we have a trend with a certain part number? And do we have a trend with a certain operator on certain features? So is it a machine problem? Is it a part complexity problem? Or is it an operator problem? Okay, so this is where your quality metric is a little bit more complex than just saying, yeah, we run at a 3% scrap rate. We're awesome. But why? Why do you run at that scrap rate? I mean, scrap's inevitable. We're not perfect. I get that completely. But is it one machine that's creating that 3% scrap? Maybe you've got 15 machines in there that are running at a 0.5% scrap rate, and your other machine, you got one machine that's running at a 5-10% scrap rate. Whatever it takes to average that up to 3%. Maybe you got a problem. Maybe you've got some significant backlash in a ball screw, and you're turning a contour on a part or you're milling a contour on a part and your profile tolerance is being exceeded every time because your machine's not comp for backlash. You're never going to know that unless you review the data, right? Okay, so that's just an example of what your quality metric is going to tell you. Some things to look at. Again, scrap is expensive. You never get that machine time back, and it costs material as well. And some materials. I mean, geez, I've done made parts that the material is $20,000 each for a big piece of 6AL4B. So you could be talking significant loss here if you don't nail down your scrap. I mean, even in a high volume production environment, everybody's seen it where a dimension gets missed, a first article inspection doesn't get done completely, and you go run 100 parts, and whoops, we forgot to check these groove widths, or this one depth, and now we just threw away $6,000 of material and 16 hours of machine time. Scrap is incredibly expensive, so this one is important. You got to think, if you spend $500,000 a year on raw material, if you scrap 1%, $5,000. If you scrap 2%, it's $10,000. If you scrap 3%, that's $15,000 every year. So if I could take my scrap rate from 3% to 2%, I save $5,000 a year just in raw material. That's not even counting our cycle time. Now what is that cycle time taking you? Usually I figure scrap to be 30% of whatever a job cost is. So if I've got $5,000 a year in scrap, I've got $15,000 total in the job. I've got $10,000 in labor. So if I can save the 1% of scrap, I save $5,000 in material, I save $10,000 in labor. I'm 15 grand ahead. Now, what if you scrap after a post process? Maybe it goes out to grind, maybe it goes to water jet, and you scrap it. You're out that money. You see how this thing stacks up, and all that saving directly to your bottom line. This is not like a pie in the sky kind of thing. This is significant impact you will feel and you will see. I'm kind of diving deep on the quality one because this is the easiest thing to fix, in my opinion. This is the fastest and most simple one to correct because it's the easiest to measure. How many parts did I make? How many pieces of material does it take me to make it? You don't have to, we're not depending on data collection and things like that, people clocking into their jobs and maintaining all their accuracy and their clock in and clock out and all this stuff. We're not depending on that. This is very easy. I can go to my PO that I sent for the material and say, I ordered 100 pieces of this. I needed 90 of them to go to the customer. Did I have to order more material? Or did I put some into inventory? Or did I overship? Did I get what I paid for? Very, very simple, right? This is probably the easiest one to measure, in my opinion. Okay, so that's kind of where we went through OEE, the different facets of it. And again, stay pretty high level on it. Kind of dove into different things that and ways that you can different things that's going to tell you, right? Different feedback this OEE equation is going to give you. Um, for the overall OEE, you need to target 80 to 85%. 100% efficiency or overall equipment efficiency. Good luck. I mean, that's good. It's damn near impossible because again, it's an imperfect world. Uh, it's almost unachievable. And quite frankly, because it's continual improvement, right? Nothing's ever perfect. No process is ever perfect. Nothing's ever bulletproof. There's always something that's going to come up, go wrong, something we can be doing better than we're doing today, tomorrow. Okay, so 85% is pretty good. You're getting along at a good clip. When you start dropping below that, you definitely need to give some attention to those items. If you start getting down below 50%, you really need to take a look at what you're doing. Because ultimately, what OEE is telling you, all of our shop rates are determined based on either number of employees or number of spindles, kind of however you want to calculate it. But if you're at 50% OEE on your employees or on your machines, wow, you're leaving 50% out there. You could be doing 50% more work with what's sitting on your floor today. So what does this whole thing have to do with the beginning of the year? Well, beginning of the year, we set our goals, right? We set our targets. And a lot of our goals and targets are based on revenue. We want to make X dollars. Well, what do we need to make X dollars? And the first thing that's always said, we need more people, we need more machines. My OEE says you're wrong. My OEE says we don't need anything. We've got it all sitting right here. We've just got to take better advantage of it. We've got to change what we're doing. We've got to change our process. We've got to retrain our people. We've got to do, you know, any combination of these things. Maybe we've got to change our quoting because again, when I go back to that performance metric, maybe we're quoting really low and we're really busy. Maybe our machines are hitting you know um, uh, great availability numbers. Maybe we're hitting great quality numbers, but our performance is low because we've underbid everything we do. Well, now we've really, we got to take a look at that. And so in that instance, maybe it is telling us we need more machines, but it's only telling us we need more machines because we're underbidding everything we do. So again, going into a new year, that's like I said, that's always the immediate feedback. Well, to make more money, we need more people, we need more machines, maybe. But what is the easiest way to increase your your availability, right? Well, availability, remember, this is an efficiency factor. If you've got somebody standing in a machine, they're going to end up at some point in the day having a conversation with somebody else there at work. Maybe they're going to get pulled away to go help somebody with something, and their machine's going to sit. They're going to go to the bathroom. They get a phone call. You got a sales guy that comes in and distracts them for 5-10 minutes. Okay, that all impacts your availability, right? So we automate. If you want to run your availability up to 100%, or well, I can't say 100% because again, unplanned downtime counts against your availability. But if you want to remove the unplanned human time, throw a robot on the thing. You know, um, again, this is what your OE is telling you. If you're consistently struggling with your availability, and it's not because of machine downtime, it's not because of say, waiting on raw material to show up or QA or any of those kind of things. If your unplanned downtime is because of human nature, maybe especially if you're in a production environment, maybe we look at automating it. These are the things that your OE is telling you. These are the things that the information it's going to give you, and you just have to know, think about how to dissect this information and how to get these results, these directions out of it. So, you know, again, going back to the main point here of year end or year beginning planning. We evaluate our OEE and we make decisions for the following year based on that. Typically at the end of every year, you're going to look at, profitability. How much did we make? Okay. If you've got X dollars in profit, general rule of thumb, you put 30% of it right back into the company. That's how you're going to grow. Again, like I was talking about earlier, we're not babying these machines. They're here to make us money. You should have a plan to replace every machine on your floor. They can't run forever. And quite frankly, sorry, if you're running a machine from 1999, 2002, that machine will not keep up with a machine made in 2026. It will not do it because there have been improvements made in the mechanics, the softwares, the hardwares, the kinematics. All these things have been improved over the last 24 years, 25 years, 26 years, whatever. Okay. So you can literally not even change your program in most instances. By putting it in a newer machine, it will run faster because the capability of the machine has improved. Okay. If you're using 4 flute high speed steel end mills, uh, yeah, you need to make some investment in tooling, because guess what? A 7 flute variable pitch end mill with a chip breaker running through, steel, doing some heavy pocketing and things like that, you're gonna run faster. Period. So all these things have to be budgeted for, right? And that's where that what I'm saying about your margin and reinvest it back into the company. These are the types of process improvement plans you have to make based on your OEE. What is causing our lag in availability and performance? Is it machines? Is it tooling? Is it training? Is it programming? Is it, what kind of things is there? Same with performance. And you have to set your targets on what you aim to improve and what kind of funds you want to set aside for those things, which is our next um, planning event, is budgeting. um, you know Tool holding, work holding, this stuff's not cheap. It's expensive. Machines, again, not cheap. This is one of the reasons I think this is one of the hardest businesses to be in, is the barrier to entry. It is expensive. It is brutal. I mean, you look at every machine shop out there, every one of them started in their garage. Why? Well, who's going to go lease commercial real estate for $5,000 to $10,000 a month when they've got maybe 2 grand a month cash flow when they're starting out? Net cash. That's tough. That's that's tough, and they're doing it in their garage, with no rent overhead. And again, going back to shops that are established, I mean, I worked on jobs where it's 40, $50,000 just to tool it up. I mean, we haven't even cut a chip, and we're putting $50,000 into this thing just to give them a first part and have them inspect it, tell if it's right or wrong. So, what the year end kind of provides you is, you do look at your OEE, but the other thing you have to look at is you have to look at your core competency. What are we good at? What are we not good at? Okay. You don't want to necessarily just be a one size fits all kind of thing. Like, this is all we do. We don't do anything but this. It would be great, but and you can, don't get me wrong. There's some shops that do that, and it's very good for them. But the reality is, the majority of shops, we can't do that, because you drive all the way down to the bottom with one customer in that one category, and then what? What are you going to grow from there? So you've got a couple things you're going to do very well. Obviously, my first opinion would be, double down on the things you do very well. But there's another side. Maybe you're a 3 or 4 axis mill shop and you want to get into 5 axis, because again, it's more efficient, it's faster, all those kind of things, and you can bring on more complex and higher margin type work. Well, you've got to invest in that capability. So you got to invest in the machines. You got to invest in tooling, because the way you approach parts, the way you hold parts, and things like that are different. You've got to invest in programming, because you're going to need a new post for the new machine. You may, depending on your CAM package, you may have to get an add-on to your current license to be able to post in multi-axis. And then you got to invest in training. It doesn't do you any good to have a 5 axis mill sitting on your floor with nobody knows how to run it. Nobody knows how to program it. Nobody knows how to set it up. Great. You just bought another three, you overpaid for a 3 axis mill at this point. So these are the things that at the end of the year, you have to think about for the next year. Like, where are we now? And where do we want to go? What is it going to take to get there? And then we've got to plan that for the beginning of the year. So again, one of the big factors is OEE. Of course, then you've got your budgeting, and again, where's your fastest ORI? That's a huge one on budget. Is you want to prioritize those ED ROI items at the head of the line, because guess what? As soon as you ROI that, you're all money ahead from there on. Right now, you can start doing some reinvestment in the middle of the year. You can say, hey, look, that was paid for itself, and every month we're coming out more money ahead than we were before. Let's take that money and put it into another improvement, and you just keep stacking those wins, right? Um, you know, what the easiest way to say your shop's growing is to go and grow your top line. We just make more money. And I've said this a million times before. There's multiple ways to look at it, but if I got a shop that's doing 2 million and I take it to 5 million in 2 years or whatever, but at 2 million, my bottom line was, 500,000, and at 5 million, my bottom line is 500,000. A couple different things to see here. Number one, your company's not worth any more at 5 million than it was at two. Maybe you get a little bit more because you got, you diluted some customer concentricity. Maybe you went and got a cert and things like that. So those things are going to add value. But you know, your bottom line is 500,000, the same as was at 2 million. Okay. I looked at a job not recently, or I'm sorry, recently looked at a job for a customer that it was right around a million top line. And when I look at this, I said, this is how we need to look at everything. Immediately coming in the floor, if we were to land this job, 100% automated, part load, unload, all that kind of stuff. Hydraulic, pneumatic clamping, all that into a machine. And I thought, all right, so we get that in, we get that ROI. The next step is automating the material handling. Going to the customer and saying, I need you to send me these parts on this pallet in this orientation. Here's a layout of how I need to receive them. I set a pallet on the floor. I have a robot put them in a rack. I have a robot load from the rack into the machine, or that same robot unload from the machine to the rack. The secondary robot unload from the finished rack back onto a pallet. Now we're ready to shrink wrap and ship. Take you one step further. We do all that same process, and then we add a shrink wrap machine to the end of the line, and it automatically shrink wraps. Now I've taken this project, right? This the $1 million opportunity, and value makes no difference. It doesn't matter how much what the value is. But I take this job that maybe in the beginning we are making a 20 to 30% margin. Second iteration, maybe we increase that to 40, 50% margin. Third iteration, maybe we increase that to 70 or 80% margin because we're effectively doing everything with zero labor. All we're paying at that point is burden. That's it. And some amount of that burden is, of course, what sort of debt do you have on all the different components and things like the machine, the automation, all that stuff. Square footage, what percentage of the building are you occupying, electricity, you know, cooling, all your cogs, things like that. So that's kind of an example of looking at these opportunities and increasing your bottom line, right? Take that $2 million shop from a $500,000 margin to $500,000 margin, or I'm sorry, a $500,000 margin to 750, right? Increase your bottom line. That's what's going to make it easier to operate. And quite frankly, that's what's going to allow you to grow, because one of the biggest constraints on growing a machine shop is cash. I mean, there's not very many people on this planet that will debate that fact with you. The biggest obstacle to growing a machine shop is cash. If you want to grow, you need to grow your cash, because again, this thing's expensive. This is an expensive ass trade. You look at like uh, electricians and plumbers, and no disrespect to those guys, of course, but I need a van, I need a bucket of tools, or a van full of tools or whatever. I'm good to go. I don't need $150,000 machine. And say you get into mill turns, I don't need a $750,000 machine. I don't need a 30,000 square foot building, to go run my business as a plumber, as a electrician, as a carpenter, those kind of things. I don't need all that stuff. A good friend of mine runs a landscaping business. He's got less money in all of his equipment than one machining center would cost. So this is a very, very expensive business. It is. And so I would say top line growth is very important, but bottom line is the most important thing. I mean, of any business for that matter. It's literally what keeps you living or dying as a business. And if you want to if you want to attain growth and keep on a growth trajectory, cash is king. I mean, that's a pretty common phrase. Everybody's heard that before. Um, okay, so we've covered the first couple basic metrics. We've talked about OEE, kind of talked a little bit about budgeting, setting budgets for the new year's. One of the other things is how do you implement that? And really, the way is through Lean Six Sigma projects. And Lean Six Sigma, I'm sorry, OEE is a Lean Six Sigma tool. And again, that's going to tell you where your problems lie, and you develop plans and initiatives based on the feedback you're given from the calculation and from your KPIs. So again, this is just kind of a broad view into this. What I'm going to do over the next couple of weeks is we're going to go a little bit deeper into all these things. I'm going to give you some tools from some other people that I know in the industry. Um, one of my good friends actually has a product that goes a long way into helping us track OEE and can actually tie a lot of things together for a lot of people. So I'm going to have him on, and we're going to definitely talk about that. But we're going to dive a little bit deeper into this, and we're going to see sort of what kind of real world impacts these things have, and maybe some lessons learned, some failures, some successes, all those kind of things. And we're going to keep going on this operations train. Um, you know, there's going to be part of it where we're going to continue talking about these high level KPIs and functions and things like that. But we can get into programming. How do you program a part? What's the best strategy to make parts? Why do you do certain things that you do within programming and machining strategies? We can get into tooling. We can talk, tooling selection, um, pros and cons of different tooling, work holding, tool holding, all these kind of things. This podcast is really meant to be like I said earlier, how you do what you do and why you do what you do. Of course, this is not like a end all be all. There's 100 different ways to make a part, and anytime in any shop I've ever been in, it's I make it this way and somebody else makes it another. That's fine, no big deal. Um, I just want to give some insight, some information of how different people are doing things. I've learned a lot over the years by just um, seeing a different perspective on a part. Like, oh, cool. I guess I would have never thought to do it that way. So anyway, yeah, we're gonna get a full spectrum on how things happen inside the door, inside the doors. Again, like I said earlier at the beginning of the show, sales and marketing very important. Without sales, we have no work. We have nothing to do. We have no job. Operations incredibly important because that's where the bottom line either happens or doesn't. And you know those things are tied completely together. So yeah, if you guys wouldn't mind, if you guys think this is good, like our show, like we always ask, please um, leave us a 5-star review so we can keep pushing this thing out to more people. And I guess I will see all you guys here in a couple weeks. Thanks.
If you have not subscribed to the podcast, please, please, please make sure you subscribe to the podcast. Those positive reviews really do fuel us forward, and we'd love a review from you so that we could go and continue to impact people in this amazing industry of machining. So we are so grateful. And again, we are doubling our content this year. No more 2 episodes a month. We're going to 4 episodes a month, and a couple of them will be sales, marketing, growth. The other 2 will be ops, engineering, and the floor. It'll really be the floor, like what happens on the floor, right? We're so grateful for all of you. So make sure that you tune in next week for another episode of Machine Shop Growth Podcast. Thank you all. Have a great week.